But what did carry growing status, and this is the important core concept to understand, was the idea or practice of technology, or in the German context, technics, the process of producing technologies. By the end of the 19th and the beginning of the early 20th centuries, technics or technology was becoming more than just an activity needed by industry. It was emerging as an activity itself worthy of social status. Consider some examples here. King Ludwig, who was king of one of the German states, Bavaria, one of the constituent states in the Second Empire, promoted an engineer to hereditary nobility, an engineer who ran the royal ore foundry. His name was Ferdinand von Müller. This foundry was the largest in the world, and it was bringing world recognition to both Bavaria and King Ludwig. This promotion was significant, as I said, because it marked the first time that an engineer had risen to the highest levels of the social hierarchy, the hereditary nobility. Now belonging to the nobility, Ferdinand's family, and most importantly, his son Oscar, became a key figure in Germany's industrialization at the end of the 19th century and the beginning of the 20th. Consider a few examples from this man's life. In the 1880s, he played a key role in building an electric power network in Germany. He was director of the Berlin Electric Power Company and the German Electric Company. A decade later, in the 1890s, Oskar von Müller set up an engineering office in Munich, which played a leading role then in the development of the German engineering industry. He directed the International Electrical Engineering Exhibition, which took place in Frankfurt, demonstrating the breakthrough transmission of a 20,000 volt alternating current power line, a dramatic development in electric power generation and distribution. In 1903, using the venue of the annual conference of the Association of German Engineers, the VDI, Oskar von Müller secured political support for establishing a state museum devoted to technology. And in order to create this museum, he secured patronage and political support from the Bavarian Prince Ludwig, which secured a continuous supply then of state funding for this technology museum. What's now the Deutsche Museum became the largest and most modern museum dedicated to technology or technics in the world. Like other German museums that were funded with patronage from the hereditary nobility, it served as an archive of the unfolding of the German spirit, of the German Geist, this time in Bavaria, and this time through technology. Now, continuing this illustration, von Müller was also later project manager at the power station at Lake Vulcan, which was at the time the largest hydroelectric power station in the world. He even served as representative to the ruling council in Germany, representing the Crown of Bavaria. He was chairman of the Society for German Engineers. He was a member of the peace delegation at Versailles. He was honorary president of the Second World Power Conference in 1930. And during this whole time, von Müller was also an educator, principal of the Technical College of Munich, which would later rise to become the Technical University of Munich. In other words, the lives of father and son Ferdinand and Oskar von Müller indicate that by the end of the 19th century, it was possible, finally, for engineers to break through this glass ceiling that had for centuries characterized the social hierarchy in Germany. There were other indicators of the rising status of technics. 1900 was a crucial year for legitimizing technical education, at least for the higher technical institutes. As I'll elaborate here below, the main educational preparation for students who were going off to university was the gymnasium, which is an academic high school, and to this day emphasizing classical foreign languages and education in the humanities. As the German historian Wolfgang Konig describes it, students headed for the higher technical institutes attended so-called realistic schools, emphasizing mathematics and natural sciences, which were long judged to be lower status. The VDI, the Association of German Engineers, which their primary agent for professional advancement, had earlier argued in 1886, quote, "We declare that the German engineers have the same needs with respect to their general education and want to be judged in the same way as other professions with higher scientific education." In other words, the engineers were pushing for higher status. In 1900, this push for school reform succeeded, as the realistic schools in which most of the engineers were trained were recognized as and granted a status equivalent to the humanistic gymnasium. Also in 1900, pathways into the government bureaucracy through the civil service opened up to graduates of the higher technical institutes. As König puts it, quote, "In 1900, when the examinations of the higher technical institutes were recognized as qualifying for entrance to the civil service, the most important demands of the engineers had been met." The point here now is that the most elite engineers, the engineers at the top, were starting to gain access to the most elite positions in the German national context. The key vehicle for this change, which had been instituted a year earlier, was to award this new degree, the engineering diploma, to graduates and to offer the possibility of that research degree, the Doctor of Engineering. Finally, during this same period, the German emphasis on scientific technology was reaffirmed in a social movement among the faculty in the higher technical institutes, especially the professors of machine construction, who called themselves, very interestingly here in retrospect, the quote-unquote anti-mathematicians. The anti-mathematicians, König tells us, opposed the idea, which is the French idea, that technology is nothing but applied natural science and mathematics. Quoting here, "The main problem of the theory of machine construction was modeling," to these German professors. "Two dilemmas attended the solution of the problems of construction. The first was that the premises of the calculations were not too certain. In other words, they depended upon a number of assumptions. The second was that the calculations used in engineering courses dealt with very simple problems, irrelevant to real engineering construction problems." A common concern. This is a common concern among engineering students today. Ernst, referring now to a professor from Stuttgart, cited the example of the progress in the construction of steam engines in the past several decades, for which the mechanical heat theory, the basic foundational theory of heat, had been not as important as the experiments, observations, and measurements of practical engineers. So the anti-mathematicians were celebrating the developments in scientific technology that did not involve and not require derivation from fundamental mathematical principles. As the German historian Peter Lundgreen explains, in mechanical and electrical engineering, quoting here, "Big firms and higher technical institutes quickly joined forces in establishing a sort of industrial scientific complex, with leading men switching jobs in both directions." So, in other words, by the end of the 19th century, the German scientific approach to technology, which was housed at the higher technical institutes, was emerging with a distinct identity, linked with industry. The founding of machine laboratories forged connections between these institutes and the rapidly growing German industries. The faculty at the higher technical institutes were now clearly both teachers and researchers. And as one engineering educator from Berlin put it, engineering education should consist of three important dimensions or methods. The first being theoretical teaching, the second, laboratory exercises, and the third, the teaching of design. All this contrasting sharply with the French model. And in addition, the German students would have to spend a year as unpaid trainees in a factory before beginning their studies. So, under the Second Empire, engineers were now working their way up the social hierarchy, but with two distinct identities, fueled and legitimized by this new linkage emerging between technological quality, progress, and nationhood. However, this French term, ingénieur, still had no specific rules for its application. Anyone could claim it, and many people did. As I've described, during the Second Empire, the higher status engineers were faring well now, gaining access to civil service, and doing work that was judged to be equal in status to the work of the universities. But meanwhile, the engineers on the lower end of the social scale were also campaigning for greater status and for more of a leadership role. They would get their day after World War I.